Rachel. I am the Quality Assurance Manager at DNA Labs International. We are a private laboratory located in Deerfield Beach in South Florida. And I'm also in charge of research and innovation now. So that means seeking out new technology, trying to look for new technology, and then bringing online things that have already come out, like Rapid. So we're a little bit different in that we're a private laboratory, so we do not have direct CODIS access. So we have to work with ENDIS participating laboratories in order to get data uploaded. So at our laboratory, going for a databasing approach didn't necessarily make sense for us on the Rapid right away. Where it does make sense for us is utilizing it for rush cases. So when we have suspects that are on a 72-hour hold and we need confirmation that they have the right person, that's where rush makes sense. I can relate very much to Brandy about midnight calls or having to come in on the weekends. We greatly appreciate being able to do this in 90 minutes opposed to the 12 hours it would normally take us. And then the other thing that comes into play is at our laboratory, we work all throughout the United States, but we also work in 10 Caribbean nations that do not have their own forensic laboratories. So when they have plane crashes and things like that, we are in charge of victim identification. And another unfortunate side effect of plane crashes and explosions and really bad car crashes is fragmentation of remains, which is a nice way of saying that a person's in 20 pieces. So we're trying to reassociate, this torso goes with this arm and things like that so that we can quickly not only identify, but reassociate remains so that they can be returned for burial to their families. When you have a family that's suffering grief and they want closure, they don't want to be told they have to wait 6 months for the remains to be released. They want to be able to have funeral services and try to work forward with their grieving process. So that was something important for us to look into. So a little bit about us, as I mentioned, we are in South Florida. This is actually an old picture for us. I think Joseph will probably recognize more people in this one. We're about 50 people now, so we're much larger. And we have been working for 15 years in forensics. And this is where we are at with the RapidHit ID system. So we actually originally got the original Intigenics instrument right as Thermo had acquired Rapid. And then we switched out instruments. So our newest version, the Thermo version, was installed in May of 2019. You'll see here it says November of 2019, finalizing validation. You might say, that's weird, it's November. Have you finalized it? I have not. We added one last component, which I'll talk about a little bit at the end. So for us, we wanted to have interest in this system because it had immediate benefits that you've already heard a little bit about. But in particular, developing a DNA profile in under 2 hours from a body fluid sample as an investigative aid is actually very helpful for a lot of the jurisdictions that we work with. And for us in particular, when we're looking at bones, most bone extractions take anywhere from 12 to 72 hours. We use a demineralization protocol, which means that we basically powder our bones to a very fine powder, almost like all-purpose flour, but then it gets essentially dissolved in our solution. Well, our extraction, we say 12 hours, but unfortunately, if you come back after your initial incubation, you still have bone powder in your tube. You have to respike, re-incubate, and keep going until we have more complete demineralization. So this protocol can take anywhere up to 72 hours and is laboratory dependent. They're also very labor intensive and hands-on. We have an organic protocol in place for that, which includes really nasty chemicals that require someone using a specialized hood to go in there and work with us. It also requires extensive bone preparation. We have a lot of luck with bones in our laboratory. We have multiple analysts that came from military laboratories and have been working on skeletal remains dating back to the World Wars. We've actually done some Spanish-American and Civil War as well. So a lot of that bone preparation is where that success comes from, the way we clean and powder our bones. However, it's very labor intensive. It also requires designated screen area. You obviously don't want bone powder snowing around everywhere when you have other evidence out. So it has to be separated from all of our other processing. So first, we went and looked at a sensitivity and stochastic study. And I want to clarify too, at our laboratory, we are not using the expert system at all. So for us, the green checks are nice. We know we're going in the right direction, but we treated it like a new amplification kit. So we have all of our own thresholds and stutter filters, and in that way we're able to get a higher pass rate. And the instrument, rightfully so, has very conservative thresholds on it. And that's because, if we want to cock-proof it, as Ben Salem said. So we want to have very conservative settings on that. However, as a DNA analyst, we don't necessarily need that conservative setting. We're going to set the stutter filters where we've determined that they're best fit based on our validation data. And so we obtain high-quality bone samples from a known source, and we ground the bone sample to small chunk consistency. We prepared 2 sets of bone samples weighing approximately 10 milligrams, 50 milligrams, and 100 milligrams. Say approximately, because when you're dealing with bone chunks, you can't get exactly what you want. So we try to get as close as possible, but you can see what the actual values ended up being. And then we ran the samples through the Rapid using Intel cartridges. We're only typically using ACE for blood and Buccal swabs, and then Intel for everything else. And we process the raw data for average heterozygous peak heights and sister allele balances. I know there's not a lot of DNA people strictly in here, so I will blur over some of that, but it's just basically like, if it's balanced, good, not balanced, bad. So that's what we're aiming for at our laboratories. We want to see really balanced profiles. If you go back to Brandy's presentation, where you saw that one peak that was getting called and the other peak that wasn't getting called, that's imbalance. So we want them to be the same height, so they're either both getting called or they're not, so that we know that we're seeing all the correct data. So small chunk consistency, what does that mean? If consistency is too fine, so when we do our regular bone cutters, we use a mixer mill, which is basically a little metal jar with balls in it that shakes the bone really, really fast and turns it into that flour. We, however, cannot use that on the Rapid because it'll clog the system, so we do this small chunk consistency. So this is my Himalayan pink sea salt picture to give you a visual kind of the size that we're aiming for that. And that's nice for us too because it also requires less prep. We don't have to use the mixer mill to get that consistency. So how is the data? Again, probably not as exciting for people that are non-DNA, but you will see here these peaks are about the same height everywhere. So that's really good for us, and that's what we want to see. And these are all different DNA locations here. You'll notice I have peaks at every location, so that's also thumbs up. This is what we want to see. And considering a lot of advanced bone protocols can't even get DNA profiles from bones sometimes, this is really good for us. This is what we want to have for data. And high quality recent remains means that it's not exposed to extreme environments. So at this point in our validation, we're not taking bodies that were found in a bog after 20 years or left out to bleach in the sun in the desert for 20 years and things like that. We're going with high quality bones, which means that they are somewhat fresh remains. So something within the last 12 months that hasn't been exposed to any extreme conditions. So this is, again, going into the peak heights that we're getting. Basically, this just means big numbers, good. And also, again, we have the peaks that are balanced here. So this is happy scientists. This is what we want to see. So also then going into set B. So this is also important for us because we don't want one good working bone. We want it to work good every time. So we have to go back and repeat the test repeatedly and see that we're getting consistent results, getting the same profiles throughout. So now this is going up to 50 milligrams, so we're getting slightly more of an input now. And if you looked at those tubes, I think I have a better picture of it later too, but this is a very small amount of bone that's going in here, which is nice too, because we don't want to say, here's your remains back, but by the way, I took a whole leg. We want to take very small amounts of samples and retain as much of the remains as possible. So again, the 50 milligram data. And then if you can notice too, this is where things start to get a little bit interesting. So all these E's and X's, these are things where edits have been made at some point in the gene marker data. So that means a scientist went through here. This didn't magically come off the instrument this way. A scientist went through and edited this data. And once you got, maybe I wrote a little bad. Into the 100 milligram data, you'll start to see that there's a lot more of those little peaks popping up. So all these little X's here and all these little X's here. So that's important to note. We want to know what the sweet spot is, so to say, for how much bone that we're actually going to put in. And when you take a closer look at this, you can see all these artifacts popping up. So a fun thing about bones is it has a lot of calcium in it, and calcium can interfere with reactions. So some of these artifacts are things that we've actually seen before, where you end up getting these large split peaks looking like this, but this one's not real. That's due to the fact that it's oversaturated data. So when we have calcium in our regular sample, sometimes the quantitation where we determine how much DNA is present isn't accurate because it's interfered with by all this calcium. So we weren't surprised to see this. We know what this looks like. It basically just means there's too much DNA in here. And when you're thinking about 100 milligrams, a very small amount of bone powder, and we're overloading the instrument because we have too much DNA, that's pretty good results. So here's just another little zoom in on that. And this one we're looking at about 93.7 milligrams. And you can see though, even though we have all these artifacts, we are able to edit it and see what this profile is. So if this is unidentified remains and we think that it's a child of alleged mother and alleged father, I can still do a paternity analysis on this and determine if we have the correct person and get a quick answer. However, because we've done this validation data, we can make adjustments now and know this is a better amount of bone to place in. So just a little look into the artifacts. And then these are average peak heights by bone amount. So you can see as the amount of bone that you put in increases, as we expect our peak heights get higher up. And we also see consistency between set 1 and set 2. So that doesn't mean we're getting completely haphazard results that jump all over the place. We can have an expected result based on the amount of bone powder that we're putting into the instrument. And I will breeze past the peak heights for the non-DNA people, but I'm happy to provide presentation to anyone who needs a copy of this or wants this as a reference point for their own data. We also looked at buccal swabs and the number of swipes. So Brandy mentioned swipes earlier. That simply means if you stick the cotton in your mouth, do you go like this? Do you go twice? Do you go 5 times and really do it? If you're a scientist, you practically like bore a hole inside your cheek to get it. But criminals, a lot of times, when they're like smearing at you and like biting on it, maybe you're not getting the best swipes. So we want to know what the data is going to look like based on how well you swipe. The ideal is that we're getting a full profile no matter how well they swipe. When we first went online years ago with direct amplification, we thought, oh my gosh, this is great, we're getting amazing profiles. Problem was, all of our samples were created by scientists who are known to swab really, really well because we want good data. Once we actually were getting it from booking stations, we had a problem because certain booking stations weren't getting as good of results. And part of that was operator error, and part of it's also just that criminals aren't as cooperative. So we didn't want to run into that same issue where we had to make adjustments down the line. So we want to look at all the different swipes, and then we're also looking at half swabs versus full swabs. So some agencies will always take 2 swabs, but some only take 1. So we don't want to consume everything. We want to be able to save some of that to come back to for additional testing. So in those instances, we would only take half a swab forward. So again, this is looking at our peak heights, which is important to us to show that we're getting good results. We also looked at blood swabs. Some of our British clients still collect blood at the hospital and do not do buccal swabs. So it's important for us to be able to get good results from blood in addition to just property crimes where everyone cuts themselves on the way into the house and then drinks a can of Monster and smokes a cigarette, which is like our usual robbery scene, or sometimes takes a poop too. We get a lot of that. So we also want to make sure that it's going to work for those types of evidence. I don't understand those. Seriously, I'll be like, it's the same guy in 3 houses. How did he poop in every house? I don't get it. It's a mystery. So again, we're showing that we're having good results on that, good peak height balance. And then going back to the bones now, this is our overall peak height ratio versus bone amount. And what this means is this talking about the balance between those peaks. So if they're exactly the same, you would be 100%. We're generally happy with things above 60 or 70% based on the kit. And you'll see here we have 83, 80, 78, 79, 81, 76. And this is, regardless of the input that's going in, regardless of the bone set. So this is very good data for us. Kits are divided into dye channels, so you see those peaks that they're all different colors. We don't want blue working really good and red working really, really bad. We want to see consistency throughout dye channels. So this is another important thing to look at from a laboratory perspective when we're validating. And by doing all this work enables us to analyze off the instrument, which is how we get such a high pass rate. So how does this work compared to what we currently do? We currently have 2 different bone extraction protocols online. They're both demineralization protocols, but one is small scale, meaning it goes in tubes this big, and one is large scale, meaning it goes in tubes this big. The reason why we brought large scale online was strictly for forensic genealogy purposes, because we would have to do 5 extractions like this to get enough DNA to do genealogy. where with large volume we can do one extraction. Regular amps and things like that in laboratory requires this much DNA, and genealogy requires this much. So this is essentially where this protocol came into place. But you'll look here, and it's overnight incubations for both. The hands-on time is about 3 hours. We have the additional processing I mentioned to get that fine powder. Multiple tubes often required, and then these PCIA washes, this is talking about the nasty chemicals that I mentioned that we have to be doing in a specialized hood. So this is obviously not as great as just getting your Himalayan pink salt consistency, chucking it in the RapidHit, and 90 minutes later you have a profile. So this is the average amount of DNA that we get by milligram for these samples. So we're showing that basically these are very small amounts for a lot of the different sizes here. And these are also from different bones. And then we're going to compare that to how we're getting from the RapidHit inputs that were tested. So you can see we're getting full profiles at 10 milligram, and that's actually a very small amount of DNA that's going in there. So a lot of times we think of things like rapid, like quick and dirty extractions, which don't have as great of results. This is actually a very sensitive result. This is very good data. So as far as quality, we have obtained the correct profiles. All these samples are samples where the profile is known to us. Multiple replicates of the same bone source produce consistent profiles, and we've had no signs of contamination. So what happens to the bone after the test? This was something that came up to mind because with our demineralization protocol, there's no bone powder left. There's your original bone that you cut from, but you don't have any powder left in the tube. However, at the Rapid, your little pink Himalayan salt bone chunks are still there. So we wanted to know what happens to that bone afterwards. So out of curiosity, we removed them from the cartridges and reanalyzed them on a new cartridge to see if we would still be able to obtain a DNA profile. Part of that is when you have a full set of remains, you have a lot of bones you can go back to. But sometimes on these like cold cases or even current cases where bodies have been moved, sometimes we're getting a piece of bone like this. It's worth holding on to those samples and not just chucking it in the biohazard. So we're trying to determine whether or not we want to retain these bone powders. So this is for a peak heights for a 10 milligram bone sample. So this is one of our smaller bone sample sizes. And you see test 1 and test 2. So we're getting a little bit less, but we're still getting a good full result on this sample. And again, here's our peak heights. We see that, again, test 2, a little bit less, but still a reasonable amount. You'll notice these ones that are bottoming out here. These are sex-determining markers. This is a female. So it's okay that those are so low. We don't expect to have a results there. So other options, comparable result obtained for high-quality bones. Some things that we've looked at was bone extracts. So for samples that we're going back to, we retain extracts at our laboratory indefinitely. We never destroy samples. So when we have bone extracts in our fridge, they were originally processed with co-filer and profiler and have considerably less locations. We could now go back by putting bone extract in theory on those, and get a global filer express profile, which has considerably more locations. That comes really important when we're looking at full siblings and half siblings. We generally want to see at least 20 locations for those types of tests. So it's nice to be able to go back to that data without having to completely go back to the bone and redo the process. Partially digested. So the first step for our regular extraction is that initial digestion. So perhaps for sometimes difficult bones that wouldn't give a rapid result, if you did that initial digestion and then put it into the cartridge, could you then see a result? So these are all things that we're looking at. So then we went on to low quality bones. I can say the results from this are not as great, but a lot of these bones that we're looking at are from, it's actually a jungle area. It's been submitted to basically really acidic soil and heat and multiple seasons. Most of them are about 20 years old. So it's not hugely surprising they didn't work in that instance. So in other words, the take-home message is RapidHit's not going to replace our entire bone protocol. However, for these fresh remains, it's going to be a great option. So what else can we use for rapid testing for bones? So as I mentioned, reassociation. So we're going to do statistical analysis of highly fragmented remains, disaster human identification, as well as rush cases. And then we can do kinship analysis, so parent, child, sibling, and half-sibling relationships to identify individuals. These are just some examples of where they've already been using rapid DNA in the country. So 85 victims to the Camp Fire wildfire, and all but 2 of those were identified using rapid DNA. California cold case all through DNA genealogy with a lot of genetic genealogy or forensic genealogy, whatever you want to call it, depending on your lab. A lot of the ones from the 70s and 80s, the suspect's no longer alive. So in order to confirm those results, they either have to find living relatives to do comparisons to, or they have to exhume the remains. So for someone who's been waiting 30 years for an answer, they don't necessarily want to wait a 6 to 12 month backlog at a laboratory to find out if the correct suspect's been identified. So this is an excellent rush option in those cases as well. So before I get to this part, the one thing I had mentioned to Thermo a little bit, so just the last couple weeks, I don't have slides on it yet. I didn't know if we were going to be able to incorporate it into our validation because these sample types are very difficult to get for validation, but we have been doing human organ and tissue testing as well. So we've done heart, liver, spleen, and muscles, and that has been really great results as well for us. I say spleen was a little troublesome because it kind of broke apart. So back to that fine bone powder, it'll clog the system. If you have a tissue that quickly kind of out, so spleen, fat, brains, things like that, we would recommend in those instances swabbing the tissue and putting the swab through instead of actually taking a cutting of the tissue or the organ forward. But we've had amazing results for that, and that's really great for missing persons cases where they think they found someone and we're able to quickly give an answer on that. So I think it's going to be very helpful for our laboratory moving forward. And I will not be at the forum this afternoon. I have to testify in about an hour and a half in Clearwater. So if anyone has questions for me, feel free to ask me now as you're heading into lunch. Otherwise, I put my email address up here too. I'm always happy to share info or let you guys have more info on the DNA side of things if you want. But any questions? Well, thank you, Thermo, for having me.